Assalamualaikum warahmatullahi wabarakatuh. So we are from Group E, and right now we are going to present our assignment 2, AI algorithms that will be focusing on supervised learning. So this is our group members, and first of all, we have Akil Aiman, which is me, myself. Next, we have Arif Daniel, Shazam Faris, and Nabil Amri. So we move on to the first introduction, which is for this project, we use a heart disease diagnosis dataset. We get this data from TensorFlow, which is an open source website. So we aim to build a model that classifies patients into two categories, which is first, those with heart disease and those without. Um, In simple terms, supervised learning is a type of machine learning that relies on labeled dataset to train algorithms. It maps inputs like health factors um, or specific outputs such as predicting whether a patient has heart disease or not.
Bismillahirrahmanirrahim. Okay, so now we will explain about the AI code and we will show the outcome of the code when we run it. So the first thing that we need to do here is we need to import the libraries. So first of all, we need to import the pandas SPD, which is it is a library for numerical computation, providing support for large and also multidimensional arrays and matrices. And then we need to import NumPy, SNP, which is a powerful library for data manipulation and analysis. And then we need also to use the Scalate, which is a library for numerical computations that will provide support for large multi-dimensional array and matrices. And then we will import the datasets, train, test, split, random forest classifier, classification report, confusion matrix, and also accuracy score. And then we need to import Seaborn SSNS, which is used for making statistics graphics. Lastly, we will import matplotlib.pyplot SPLT for making statistical graphics. And then the next step is to load the dataset. So here our dataset is taken from the Google API as website. And then this code here will read the dataset in the form of CSV file. And then the next step is to understand the dataset. So for the first thing is to print these few words, first 5 words of the dataset. So as you can see here, this is the output. And then we need to print the data.head function, which is to display the first 5 rows of the dataset. So here is the first 5 rows of the dataset, including this one too, first 5 rows of the dataset. And then print the dataset info, these words. So here is the words. And then we need to print the data.info function, which is used to display detailed information about the dataset, including the number of rows and columns, and also the column names and the data types, and then the number of non-null values in each column, and also the memory usage of the dataset. Here, the memory usage for the dataset. And then we need to print this word summary statistics like the one in here, the output. And then we need to print the data.describe function, which is the function is to compute and display the summary statistics for numerical columns in the dataset, including the count, the mean, standard deviation, minimum, maximum, and also the percentiles. Yeah, 25%, 50%, and 75%. Here is also the continuous of the output. And then next step is to pre-process data. So we need to run this data.select_d types, which its function is to It is like a method to filter the data set to select columns based on their data type. The include object here is to specify the only columns with the object data type, typically is for string or categorical data and pandas that will should be selected only. And then the dot column here, it will extract the names of these columns. And then we will print the words categorical columns and also the uh, the variable here, categorical column, which is the function that we just do just now. And here is the outcome. And then we need to encode the categorical columns using one hot encoding, which is we use this PD. This is a pandas function, pd.getDummies. It will convert the categorical variables into a series of binary columns, which is a dummy variables. So each category in the original column is converted into a new column with values 0 or 1. It will indicate the presence of the category in each row. And then this column here, columns equal to category columns here, it will specify which column in the dataset should be one hot encoded.
Assalamualaikum warahmatullahi wabarakatuh. My name is Shazwan Faris and I'll be continuing our group presentation. So I'll start from this part of the code, which is to check for missing values. So in this code, data is null will generate a Boolean data frame of the same shape as data, and each cell in the data frame contain true if the corresponding cell in the data is a missing value and false otherwise. And dot sum calculates the total number of true values for each column, effectively counting the missing values in that column. And print missing values, this line prints the heading of the missing values, followed by the result of data is null and sum. This is the example of the output of for this code. So it confirms that there are no missing values in the data set. And next part of the code is split data into feature X and Y. So the data drop columns equals to target. Data is assumed to be pandas data frame containing our data set, and the drop removes a specified column, specified column or row from the data frame. And the columns equals to target, specify the column name target to be dropped. And next is y equals to data target, and this selects the target column from the data and assign each to a variable y. And train test split, next part of the code where we split the data set into training and testing sets. So train test split, this is actually a function from sklearn model selection, part of a scikit-learn library, which is used to split data set into training and testing. And the parameter used is X and Y. The X is the features and Y is the target. Test size equals to 0.3 here. Specify the proportion of the data set. 0.3 means 30% of the data will be used for testing and other 70% will be used for training. Random state equals to 42 ensures the reproducibility of the split, and stratify Y ensure the class distribution in Y is preserved in both of the training and testing sets. And next part of the code is where we train the random forest classifier. So random state equals to 42 here acts as a seed for the random number generator, ensuring same set of the random decision are made each time the code is run, and the n estimator equals to 100 specify the number of decision trees in the forest. Model fit X train and Y train here. Dot fit refers to the train model on the remaining data set. X train is the features and Y train is the target values. Random forest classifier here is an instantiation of the random forest classifier model in scikit-learn with a fixed random state parameter. So Y42 is actually 40 because 42 is an arbitrary number, commonly used value for random fixed or fixed random. and any integer can be used. And next part is where we make prediction. So here model predict is a train random forest classifier. Dot predicts is a method on model is the method of the model used to predict predictions, and X test here refer to the testing sets of features typically unseen by the model during training, and Y pred stores the prediction made by the model. So I think that's all for my part. I'll pass to the next presenter.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nabil Amri bin Muhammad Izwan. It's number 2212011. And for my part, I will present starting from the step 7, which is to evaluate the model. So first of all, this step is focused on evaluating the performance of our machine learning model after training it from the previous step. So first, we can see the first code is accuracy equals to accuracy underscore score. And it's take the Y test and Y prediction. So the accuracy score function computes the accuracy of the model's prediction. Accuracy is the percentage of correct predictions out of the total predictions, which are Y underscore Y test is the actual values or labels of the data, and Y prediction Y underscore pred is the predicted values by the model. And then we can see we also have the conf underscore matrix, which is stands for completion matrix. It is function to compute a matrix that summarizes the performance of a classification model. It shows how many correct and incorrect predictions the model made, broken down by each class. The confusion matrix will have four values, which is first true positive with to correctly predict positive cases, false positive. Incorrectly predict as positive, false negative, incorrectly predict as negative, true negative, correctly predicted negative cases. And the third line is class report. The classification report gives a detailed performance report. It includes several important metrics, such as precision, recall, F1 score, and support. Precision is the proportion of correct positive prediction out of all predicted positive instances. Recall the proportion of neutral positive cases that were incorrectly identified by model. F1 score is the harmonic mean of precision and recall, equivalence for metrics, and lastly support is the number of true instances for each class in the test data. And then we can see on the bottom block, we have the print statement, which just to print the confusion matrix and classification reports. As we can see down here, it is the confusion matrix is 64 to 1213, and the classification report, which has precision, recall, advanced score, and support, so the accuracy and the weighted average. And then we can visualize the confusion matrix. So just for the start of the matrix, we write plot figure as NS heat map to create a heat map of the confusion matrix using Seaborn's heat map function. And then the tick labels and X label, Y label is the label for X and Y axis. And then plot.show is to show the heat map. And then in step 8, this step helps identify which features contributed the most to the model's prediction. Like the feature importance is to calculate the importance of each feature used by the model. And then the result is sorted by the importance values in descending order. And then bottom line, we just print it and here's the output. Feature importance. And then we can plot the feature importance by using plot matplotlib as well. And we can see at the bottom here, we use plot show, and other than that, just the labeling and the style of the plot. So now let's demonstrate the whole code to run it. So first of all, we just import everything. Next, we load the dataset from, in our example, the URL, and this can read the URL and save it as data. And then we print the first five rows of the dataset, which can You can see here the age, the gender, and etc. And then this is the dataset info, which it is in the class of data frame in pandas. And then in step 3, we can pre-process the data. And this is the output. Next, we assign the data to a new categorical column. And now we check the missing values, which we can see here. There are no missing values available. And then we need to split the data into features S and Y to make sure the reading is easier. And then we split the dataset into training and testing sets, which we use test sets of 0.3 and instead of 42. And then we train the random forest classifier. Now we make the prediction using this output. And then we evaluate the model, and then we print it so we can see the confusion matrix and the classification report. Next, we visualize the confusion matrix. As we can see here, this is the confusion matrix. And lastly, we can print the feature importance. This is the all of the features importance. And lastly, we can plot the new feature importance, which we can see here. I think that's all from me. Thank you. Sorry to talk like that.
Last but not least, our supervised learning model accurately predicted heart disease using labeled health data. Logistic regression showed strong precision and effectively identifying positive cases. Despite of the good performance, there is still a room for further improvement to enhance its accuracy. So that's all from us. Thank you.